All right, time to celebrate sixth grade. We are on the last lesson of chapter 11, 11.7. So for our IHT video lessons, this might be the end. I'm recording this back in November, so I'm not going to say for sure where we'll be at by then, but this is the last one for chapter 11. So yay! The last lesson here is just problem solving. And it's not just volume though, it's a mix of volume and surface area kind of problems. So you really have to pay attention to what the problem is asking to make sure you use the appropriate formula. All right. So really their essential question, how can you use a formula to solve problems involving area, surface area, and volume. So you need to figure out what they're asking so we know what formula to use. So our first problem here, Shed Aquarium in Chicago has one of the country's few full-scale animal hospitals linked to an aquarium. One tank for sick fish is a rectangular prism measuring 75 meters long, 60 meters wide, and 36 centimeters high along the outside. The glass on the tank is 2 centimeters thick. How much water can the tank hold? How much water is needed to fill the tank? So they have two questions there, but they're both the same thing. They're volume. What is the volume that it can hold and the volume that will fill it? So we're looking for volume. You know I don't always go through all of this stuff, but realize because we're talking about how much can it hold, we are looking for volume. All right, so right here, choose the measure that specifies the amount of water that will fill a tank. That's going to be volume. And since it is a rectangular prism, I know that my volume formula is length times width times height. Now, the tricky part for this guy, though, is that I need to take out the width of the glass. All right, so if you look carefully at our picture here, I'm going to zoom in for a little bit. We have our lighter blue and then the darker blue. They kind of showed almost like two tanks because they're trying to show that thickness. So on the outside, the tank is 60 by 75 by 36, but all around my glass is 2 centimeters thick. So this wall, this wall, this wall, this wall, and what you can't forget about is the bottom too. All right, now it's open. Well, they're only asked us to find volume, so that doesn't really matter. But don't forget about off the bottom. Well, you know what? It does matter because I won't take my 2 centimeters off the top like you do at the bottom. So here's what I'm talking about. So my dimensions, I have to consider what we need to take away because of the thickness of the glass. So the 75 meter side here, I have 2 centimeters thickness right here and right here. So I need 75 minus 2 and 2 is 4. So 75 minus 4 centimeters means the inside distance from here to here, from here to here is only 71 centimeters. Now, the 60 centimeters across, same thing. I have 2 inches here, and I really have like 2 inches in here. So I need to take my 60 and subtract 4, so 56 centimeters. Now, my height, this is where it's a little different because it's open at the top. I have my height, and I have a 2 centimeter thickness glass on the bottom, but because it's open, I don't have to take 2 away at the top. So now I'm just going to take my 36 minus 2, not 4, to get 34 centimeters. So volume is length times width times height, 71 times 56 times 34. Always pulling out that handy dandy calculator. 71 times 56 times 34 is going to give me the big number. So 135,184 cubic centimeters because it's volume. So there'll probably be a better way to measure that really, because it's so big. Like they might go to, liters and stuff will be volume, but cubic centimeters, so many cubic centimeters makes a liter, things like that. But they are just going to go with cubic centimeters here. And as I'm taking a closer look here, I just noticed, I think this is a typo. This equal sign, I believe, is supposed to be a times sign. So please change that because they have the short there. So 70 of the short line. So 71 times 56 times 34 equals. I don't believe there should have been an equal sign there because it doesn't make any sense for it to be that. All right, next example. All right, so I'm going to skip page 636 and I'm going on to 637. I want to do this first example up here. And it's similar to the one we just did, and that's okay. An aquarium tank in the shape of a rectangular prism is 60 centimeters by 30 centimeters by 24 centimeters. Top of the tank is open and the glass used to make the tank is 1 centimeter thick. How much water can the tank hold? So first thing I'm going to do is make a drawing. Okay, so if I have my drawing, I'm going to make my rectangular tank, all right? And so 60 centimeters by 30 centimeters by 24 centimeters high. Now, often it doesn't matter which dimension we put where, but because the tank is open, we do have to be careful. We have to be careful that we're using this height of the tank high, 24 centimeters high. That one does need to be this one and be considered where it's at when we take away our thickness of our glass. So glass thickness, glass is 1 centimeter thick. All right, so I'm just going to do all my work down here. Volume equals length times width times height. This was my length, this was my width, this was my height. So now length equals 60, but I need to take on this side I'm going to have a centimeter of thickness, and here I'm going to have a centimeter of thickness. So my length is going to be 60 minus 2, which is 58 centimeters. My width is going to be my 30 centimeters, but in centimeter here and a centimeter there. So that becomes 30 minus 2, which is 28 centimeters. And then my height, I only have my centimeter glass down here because it's open on the top. So I only want 24 minus 1, not 2, which is 23. Oops, sorry, not always on the page. Volume equals, and so I'm going to use these three numbers, 58 times 28 times 23. Volume equals, and I pull out my handy dandy calculator, and I get, let's see, 58 times 28 times 23 equals 37,352. It was centimeters, and it's volume, so it's cubic. So there is my final answer on the volume that that aquarium could hold. All right. I think it would be a good idea for you to do number 2 here. All they're doing is to provide greater strength. The glass bottom was increased to a thickness of 4. So the sides aren't being changed, just the bottom's being increased. So you are going to change some of these numbers. I'm not going to say which one, so I'd like you to do that one. Number 3, they're giving you a rectangular prism, and they're telling you that if the top of the tank is open, how much tinting is needed to cover the glass. So now this is not volume, right? This is covering. So this is going to be surface area, all right? So I do want you to do this one. Actually, they're not even asking you to find how much. They just said identify the measure surface area, but you can actually find it. I want you to find the surface area here. And then down here, they give you some information on a square pyramid. They give you bases, heights. What is the area of glass used for the 4 triangular faces. So this sounds like, to me, a lateral surface area. So check that out, try that out. Then if you go to page 639, that's our practice page, and let's just do numbers 2 through 5 on there. So 2, 3, 4, 5. You can do all those. Again, pay attention. Are they asking you for volume? Are they asking you for area, surface area, lateral surface area? All kinds of different things you need to consider. And that's going to be a wrap for our video lessons. And then maybe next class we can do chapter review, starting on page 641. And then after that we will have our chapter test for chapter 11, and it'll be a wrap. Take care.